Hello everyone, this is the review class for homework 3 and today's topic is health insurance and physician market. So first of all, we are looking at the market equilibrium, the basic economic demand and supply equations and how it works. So here the graph you can see in every economic class, and here the y-axis denotes the price and x-axis denotes the quantity. It starts from 0 and is the demand curve and is the supply curve. So we all know that where supply and demand intersect, that is the equilibrium point for market equilibrium, and if we draw these two lines, then we can find the equilibrium price and equilibrium quantity on x and y axis respectively. So now I am going to solve the two equations. For one is demand side equation, let us say 600 minus twice p, the demand equation, and supply equation is 100 plus thrice p. So we all know that if we equate these two and solve for p, we can find the equilibrium price. So 600 minus twice p equals to 100 plus thrice p will give us 5p equals to 500. So p equals to 100. Now if we plug in this p into any one of these equations, then we will find the quantity, equilibrium quantity, that is 600 minus 200 equals to 400. So we can solve these equations. We have to have two equations, and then we can solve for p and q, that equilibrium price and quantity. Now we are going to solve this for insurance mechanism. We all know that there are different way of giving insurance. One is co-insurance. And what does co-insurance mean? Co-insurance means the percentage of the payment which the beneficiary or the enrollee have to pay to the provider instead of paying the full amount. So if it is 10% co-insurance, so the consumer have to pay 10% of the price. Now what happens to the demand and supply curve? So if it is the actual demand and supply curve, when the co-insurance kicks in, then the curve goes that way. If depends upon the percentage of co-payment. So if it's 10% only, so it would be here, and if it is full free, that is 0% co-insurance, then the curve will be just vertical. So this amount designate that at zero price you are demanding this amount. So this will shift from the actual demand curve and in this fashion. So now what happens to the equation? We can let's say there are 50% co-insurance. So our equation was for demand equation 600 minus twice p, and as it is co-insurance and paid by the consumer, so it is playing on the demand side only. So I have to plug in the 50% co-insurance in demand equation. So what would be our price? Our price would be, this is the coefficient, so I have to keep these coefficients intact, but I have to change the price. What is the price? Price would be 0.5p. So if I do the simple math, it would be 600 minus p. So my new demand curve, that is shifted from the earlier phase. So look here, the coefficient is changed. We all know that coefficient is the slope of the demand curve. So the slope of the demand curve changed, so the demand curve shifted. Now supply curve is in the same place, supply curve is the same, so 100 plus thrice p. Now we have to equate this one, the new equilibrium, say this one. So our new equilibrium price would be here and here. So if we equate this again, now we have the equation for the new demand curve, that is Q1, and let us say it is demand 1. So it is Q1 and equals to Qs. Then we find that 600 minus P equals to 100 plus thrice P, and solve it for 4P equals to 500. So P equals to 500 divided by 4, so 125. So this will be the price for 50% co-insurance market. And if I plug in this price into the new demand curve, new demand equation, or in the quantity supplied, I shall get the quantity demanded. So that is easy. Now we are going to the co-payment section. There is another way we can have insurance. What is co-payment? Co-payment is a fixed amount. There is no percentage, there is no concern about the actual market price. Say the insurance company says that you have to pay $60. So this is your co-payment. So every time you go for physician consultation, you pay this, your out of pocket. So it is reduced from the other earlier price. So if it was the market equilibrium, now we solved that P was 100 and Q was 400. So at this level, at the market without any insurance, we are paying $100 for each physician consultation. Now there is co-payment, let's say 60. So our demand will be at this point, and then it will rise up, because at this point 60 is the fixed, then we will, whatever the price is, we will demand this amount. So it starts from here and then it goes vertical. Now how can we do the math? If it is QD and we look at our earlier equation, 600 minus twice P. So now our price is 60. So we put 600 minus twice into 60. So P is literally 60 without any mention of P, because it is fixed. It is fixed at 60. So it is 600 minus 120, it is 480, and QS equals to I just 100 plus thrice P. We have to equate these two, and we will find 3P equals to 380. And if we solve this will be 126.67. So QD, for QD we have to plug in this into this equation, and we will find the quantity demanded at this price, at this $60 co-payment. But what happened if the co-payment is more than 100? Here look, 100 is the equilibrium price. If somewhat 110 is demanded, then what will a rational consumer will do? Will he buy the insurance? No, he will not buy, because it is $10 higher. If I buy insurance, then I have to pay $110 instead of 100. So why I am going to buy this insurance? I won't. So there would be, the insurance will not run. I will stick to this market, and $100 will work. So if anything, any irrational number more than the market price is charged as co-payment, we will not buy this. So that is for co-payment. And now we will go for this another kind of insurance, that is indemnity insurance. What happens in indemnity insurance? For indemnity insurance, you pay out of your pocket, and then you are reimbursed an fixed amount. That is also fixed amount, but now you are paying, if your payment is 100 and indemnity is $40, so you are paying 60. So how I come up with this number? I am deducting 100. I am deducting 40 from this 100. So this is my effective price. So I have to find this effective price, and in quantity demanded equation, that is 600 minus twice P, I have to put, say my indemnity is $40. So I have to put P minus 40 in the equation. because it is my effective price. Now I am paying $40 less of the price. So now my demand equation is twice P minus this 80, so 680 minus twice P, and quantity supply curve is the same, 100 plus thrice P. We have to equate these two, and then we will find the price, and then putting the price in any of the equations, this one or this one, we will get the quantity demanded. So this is the case for indemnity insurance, where I am getting reimbursed a fixed amount, so my effective price is reduced from the earlier market price. So this is all I think for health insurance part. Now we are going to see the physician market, how physician operates and what is their. So we all know about the perfectly competitive market. In economics, there are some assumptions that there are many buyers and many sellers, and they can anytime enter and exit from the market, and they sell identical products, and there is perfect information, there is no information asymmetry. So these are the assumptions for perfectly competitive market, but in reality there is no perfectly competitive market. So for physician market, there are two kinds of market that in operation. One is monopolistic competition. Monopolistic competition. Here the notion is physicians are selling no identical product. So they are consulting, maybe they are producing, maybe they are prescribing the same drugs, same tests, but maybe their co-workers, their behavior of the co-workers, even the physician's behavior is not that good. So there are many other factors. So the product he is producing is not actually same. So they are selling different product, not identical products to the seller, to buyers. So in monopolistic competition, we all know that there is a demand curve and this is a demand curve, and there is a marginal cost curve. Marginal cost curve, that means your marginal cost, you know all about marginal cost, that additional cost for producing an additional here consultation. So marginal cost curve, and why is the marginal revenue curve? We all know that the market for monopolistic competition market equilibrium is at the marginal revenue curve. So that would be, it is the average cost curve, and marginal revenue curve is somewhat below the demand curve, that my average cost curve, that is marginal revenue curve. So here is the equilibrium, and it is arbitrarily drawn, and as we don't have the it is drawn arbitrarily, but we are going to the equation later. Now it is the equilibrium point. The physician is producing this amount of quantity at this marginal cost, say it is P0, and what amount of it, this is the amount of this is the price of producing, and they are not selling this quantity at this price. For that price we have to go to the demand curve and find the price for this. So this one is P and this one is Q. They are selling their price at P, and this amount they are paying. So if we have to find the income of the physician, that is their total revenue. They are producing this amount of consultation at this price, so they are getting all this amount, and this is their production cost, and this is their total revenue, and this one is his income, or you may say profit. So we have to deduct this portion from the total revenue part. And now how we can get to the total revenue? For total revenue we have to find the what is the marginal revenue. then we have to find the marginal cost. We have the marginal cost, it can be given. What is the marginal revenue? Can be any marginal thing, can be derived from its total thing. Here it is marginal revenue, so we have to find it from total revenue. From total revenue, if we differentiate this one, we can find the marginal revenue. So if it is given that D, the demand equation again, D equals to 500 minus 2F. So what will be your total revenue? Total revenue will be your demand into your price. Here is multiplied demand into price, so it would be 2F square, 500F to F square. Now we have to differentiate it to get the marginal revenue. How we differentiate it? We differentiate in respect with F. So I am getting to another page where we were at this point. Right. So now using the simple calculus, we can find that. I am just mentioning it. We have to put this exponential thing in multiplicative form, and then minus 1, it should be 1 from the exponential. So it will be clear from this point. This one would be in this fashion. So the ultimate thing will be 500 into F minus 4, 500 will be F0 and 4F is 1. So we all know that F to the power 0 equals to 1, so 500 minus 4F. This will be our marginal revenue, and then we have to equate it with marginal cost. Say marginal cost is 20, so we have to equate it with 4F equals to 20. Then we can get the F. Here F is P or price, and when we go get the F, we can always plug it into the demand equation. You know about demand equation, then we can find the quantity demanded. So what will be the income or market expenditure? We have to just multiply the price and the quantity demanded, and the whole this amount of money is exchanged within the market at this price and this quantity sold or produced and sold. So this one is for monopolistic competition, and another way physician can sell their product, that is their consultation, that is called perfectly discriminating. What is perfectly discriminating? That is, physician can sell their product at different price to different individual according to their willingness to pay. So we draw this marginal cost, and at this, when physician pose this behavior, they are operating along this average cost curve, that is demand curve, and physician sell his product to this individual, say at this price, then he also sells at this price this amount, this price this amount, this price. So he operates all over it up to the point where his marginal cost curve lies, because below this point he will not operate. It will at this level, and below this price level he will incur loss. So here he will not operate, he will operate just above this point and along this point. So this one is his production marginal cost. I already know that this one is production, and this there is no fixed price, he is operating at different prices. This one is quantity. Now this one is this area is revenue, this one is total cost, and this area is operating, sorry, I mentioned in wrong that he will operate also this point, not this area, not the beyond this point, because it is equilibrium. So he will operate in this area also. So this, so he will earn this amount of money also, and he will sell his product this point. He will not go beyond this margin. So he will produce only this amount, and he will sell this amount, different amount at different price. So the whole area will be his total revenue, and this one is total cost. This whole pentagon is his total revenue. So what will be his income? This triangle above this marginal cost curve will be his income or profit. So to find this, we have to, we don't have to do the calculus for this one, because here our demand curve is the marginal revenue curve. So marginal revenue is equal to marginal cost at this point, and if we solve the equation marginal cost and marginal revenue equation, we can find the quantity, equilibrium quantity, and then from that point at zero price we will find this amount. At zero price they will produce this amount of. So we all have the information of these dimensions, and employing the, that is base and height of the triangle, this formula we can find the area of the triangle, and that is the income of the physician, perfectly discriminating physician in that case. So here is another part, and now I am going to show the how to find the allocation of number of physicians among the areas, different areas. So I am not showing the math here, but I am showing the formula or the way to do it. In the class it was shown that area, population in the columns, and income per capita. So in the question there are two index. One is population index. Here that is said that it is proportional to all the area, population of area. So demand for proportional to the population in an area. So population index will be the actual population. We can put it here, population index, as it is population. So if the population is 100,000, we can put the population, this is population index, we can put 100,000 here. But for income index, there is a slightly complex formula, but not that complex. We have to put income elasticity in multiplicative form with the population of the area, and in multiplicative form there is a ratio, that is income per capita in one area, that is say A, and income per capita in the base area, that is say E. So we have to put all the figures there and find the income index for each area. So we have to have another column here, income index. Now it is getting clumsy. I am getting to another page, and for area, population, income per capita, we have all these, and population index, now income index. Now what we should do? Now this we have to find the total index. We have to just sum up these two indices, and we can find this total index, and we have to sum up this total index and divide by the total number of physicians. There is 500 physicians, and we can find the allocation there. And if we, and this amount, if we divide each area's total index by this amount, we will come up with some numbers. And if we sum up those figures we can find out 500, but the problem is the number is not full round numbers. So physician cannot be fractioned. So there should be full, one physician cannot be fractioned. So we have to keep the number without any rounding full number. So it was for 421 and then say 74. So if these numbers beyond the dot or point, these are the numbers you have to keep in. Then we have to calculate that whether all physicians are allocated. We can sense that we have kept aside the fraction, so it will not be whole 500. So if it is less than 500, we have to allocate the rest of the physicians one by one. And how? So if it is 490, then we have to allocate 10 physicians again. Then how? Here we allocate 421, say, then we have to divide this total index again by 421, because the otherwise total index that was divided by 500 is for total index for area A, we have to divide that by 421. We have to divide total index for area P by 74, and if it is 50, we have to divide it by for C. So we can get the different number for different after allocating this number, these full numbers after the initial calculation, we will come up with some different total index for that is being if 421 physicians are allocated in the area, then their now income per total index per physician will be this. Now the figures are different, so whatever the figure is higher, we will allocate the next physician to that community or to that area. Then again we have to calculate the income per capita for that community, because we have increased the number by 1 and the rest of the areas income per capita remains same as before, but only change occurs to the area where I allocate the latest physician. In that way, we have to find out which among the 5 areas, which area has the highest per capita income. Physician will tend to go there. So total index, where the total index is higher, the next physician will go there. Then we have to calculate the index again and allocate the next physician in the next area according to the higher total index. So in that fashion, in that iterative process, we have to allocate the rest of those number of physicians. So in that fashion, we can find that how many physicians at last we will come up with the total 500 physicians will be allocated among the areas, and we will come up with the number of physicians to each areas. So this is all. I think this will help. And the last question was bonus question, and bonus question should not be discussed, and that was not a mathematical question, and you can find in the text and come up with your own examples that you can think about, that physicians induce to for their own benefit, induce the consumers to consume more, and those kind of examples. And so hope you best with your homework, and for the next final exam, I hope that we can come up with a new review session like this. And thanks to Rick for recording this for us.
Well, good job. You didn't even lose your beat when that guy was knocking on the door. All right, good night, folks. So you can tell them good night.
Good night.